So, welcome back to the second part of my reflective blog, and now we're going to be talking about my second innovative idea that I wish to reflect on with you guys. So, innovations in hortagogy and andragogy are important, particularly when it comes to barriers to learning. So, my second innovative resource that I've developed was based on this rationale that there are many barriers that exist that can prevent effective learning in adults, and primarily I've seen it manifested, particularly at the beginning of courses, as a lack of confidence in a student's own abilities. So to counteract this, to try and use innovation and a resource to get through that, I wanted to consider this change in the GCSE biology specification, which now has a greater expectation to cover a multitude of maths topics. And in general, students who are returning to education often have very little confidence in maths as they've not studied it for years. So traditionally, I would present the students with something like this: a plan that includes the subject and their learning objectives, with some inspiration that would often scare them off by going, what on earth is that and what's he talking about? And then expect them, through talking at the front of the class, to understand what surface area is, why it's important when looking at animals and their environments they live in, and how does the process of surface area work. Specifically, looking at something like surface area to volume ratio. Now, this generally looks at whether an animal is fatter, which does that mean it's got a greater or lesser surface area to volume ratio? In this case, it's lesser. And thin, does that mean they have a greater surface area to volume ratio? And actually, it means more. And then try and get them to work through an activity such as looking at cubes, encouraging them to work out, using maths, why the 4 small cubes have this larger surface area to volume ratio, and then giving them the answer. So it would normally go something like that. However, this year I've tried to be more innovative and to try and differentiate and motivate the students to experiment more with maths without being too concerned about the numbers. So when looking at this idea, I thought of Play-Doh. So here you can see just a normal pot of Play-Doh, and I've taken it out, and students generally mess around with it, have a lot of fun. And then I would advise them to put it into a ball. Just roll it around until you get a nice ball shape. Once that shape's there, I then start asking them about how big it is, the volume of that ball. Then ask them to increase the surface area. But because the amount of Play-Doh stays the same, it's still the same volume. And they experiment, and they come with tubes and cubes and all lots of different things. But one thing I hope they could get used to is to maximise a surface area without changing the volume, as in the amount of Play-Doh. They could just flatten it. Massive changes in surface area. And then hopefully later on students start experimenting more, thinking about real animals, how they look, their shapes, the environments that they live in. So this idea of maximising surface area is really important, particularly in humans. You can see it within the digestive system. So these ideas, these mathematical understandings, without using the maths itself, hopefully they can understand by having thinner walls, larger surface areas, that animals and humans and the organs within them can adapt differently. So, how did it work? Generally, I think the student found it was exciting. As you would expect, they were all playing around for ages, building various things and throwing it around the room and mixing colours. But overall, it was something different and engaging for them. It simplified this complexity into something more tangible. As an evaluation, they tended to say it was informal and engaging. It was fun and confidence building, and that's how I felt at the end of it. Overall though, on reflection, I thought it maybe didn't demonstrate the higher level of understanding. Although it differentiated by result, I think in future it might be more effective to kind of look at a rigorous assessment to evaluate that understanding. But honestly, it's a fun, easy to set up activity that I think engenders understanding of quite a complex mathematical concept in a really fun way. And hey, it might even encourage them to be more creative. So, in future, I'll probably gain further feedback from the students as to their understanding of the subject area after this activity. But I don't think I'd actually change how I carried out the activity, just how I then analysed it afterwards. So, what do I think is important for a resource to be innovative? Well, I think it needs to be appropriate. So if you're using digital technology, are you going to use Caboodle as an assessment tool? Are you looking for feedback from the students? And are there limitations? Do all students have mobile phones? If they don't, are you then excluding students? So is Plickers something that doesn't use technology for the students, but only on the educator's behalf? Is that more appropriate? So this idea of Plickers versus smartphone applications, it's a very easy way of utilising very powerful technology, but it needs to be inclusive. So maybe different tools for different cohorts. It needs to be accessible. So can everyone use it? So I don't mean just do they have a smartphone, but do they know how to use the resource properly? So if we have these amazing Moodle VLE sites with all the slides and all this information on them, can they get to it? Can they log on and utilise it the way it's desired? Finally, it needs to have value. Has it got enough rigour? Does it differentiate? Can you evaluate the learning? And I think we've seen with both of the examples I've used today, that's not always the case. And that's where the reflective model is so important. So, thank you for watching. I'm off now, and now you will see the references I've used throughout this